Hi, thanks for viewing my digital library related topic presentation. I'll be discussing optical character recognition, often abbreviated as OCR. So what is OCR? OCR is the mechanical or electronic conversion of images of typed, handwritten, or printed text into machine-encoded text. It enables text to be electronically edited, searched, stored more compactly, and used in machine processes such as cognitive computing, machine translation, text-to-speech technology, and text mining. While you might assume OCR is relatively recent technology, it has a fairly long and complex history beginning in the 19th century. Here you can see a few of the major developments in OCR technology. Interestingly enough, early OCR was really moved forward by two different groups: advocates for the blind and visually impaired who wanted to develop OCR for accessibility purposes, and the United States Postal Service, who realized that OCR could expedite mail sorting. But by the mid-1970s, OCR was being used in one way or another, scanning prices, passports, and other documents by many different user groups. OCR technology has been developed into many specific OCR applications. From a digital library's perspective, the most relevant and maybe obvious application is image-to-text searchability. But there are so many uses for OCR. At this point in time, OCR is so well integrated into our daily lives that we don't even realize we're using it. For example, license plate scanning for tolls, traffic violations, etc. is an application of OCR. Other applications include data entry, information extraction, and translation. So how does OCR work? There are, of course, different OCR tools and software with slightly different methods, but in general, it's a three-step process. OCR software usually pre-processes images to improve the chances of successful recognition. This can include alignment to make the lines of text as horizontal as possible. Binarization converts the image from color or grayscale to black and white. And layout analysis recognizes tables, multi-column layouts, and more. Next is the actual character recognition. There are two basic methods of character recognition: matrix matching and feature extraction. Both of these methods analyze a character and compare it to a stored standard of that character. But feature extraction is a more involved and usually more accurate method. Post-processing can have several different steps to improve accuracy. Sometimes OCR software will compare the output to a list of allowable words or a lexicon. This could be every word in the English language or a control vocabulary depending upon the task. Near neighbor analysis can make use of co-occurrence frequencies to correct errors by noting that certain words are often seen together. With OCR, accuracy is the primary goal. While most OCR software reports rates of 98 to 99% accuracy measured at the page level, it's difficult to determine OCR accuracy because the accuracy really depends on the quality of the image or text that you start with. So a lot of this is really comparing apples and oranges. I'll briefly mention an article I found and thought was interesting: Impact of OCR Errors on the Use of Digital Libraries Towards a Better Access to Information, because it emphasized how important OCR can be for digital library access. This study analyzed the OCR accuracy at Gallica, the Digital Library of France. The goal was to predict the relative risk that search terms mismatch targeted resources due to OCR errors. I included this chart below, which shows the error rate. You'll see that the error rate ranged from 1 to 4%, which, considering the age of some of the documents OCR'd, is not that bad. As OCR technology improves, so will accuracy. As an example, we know that CAPTCHA, type this to prove you're not a robot, used to be the standard. But because OCR is now so accurate, maybe you've noticed that the new Prove You're Not a Robot task now involves clicking on which pictures have a car or something like that. Because newer, more accurate OCR technology can sometimes outsmart traditional CAPTCHA. Another example of OCR in our daily lives as well. That's my summary of OCR. You can find my sources in the Google Doc, and thank you for watching.